Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 14 on complex analysis and today's topic of discussion is complex integration. First, let us understand how this complex integration is different from the real integration. Students, in our high school mathematics we had learned the real integration, and in case of real integration the lower and upper limits, that means x1 and x2 are real numbers and the function f of x is the real variable function. On the other hand, in case of complex integration, the lower and upper limits, that means z1 and z2 are complex numbers and the function f of z is the complex variable function. Okay? Next, let us learn how to solve a complex integration. Students, for solving a complex integration, we have to follow three steps. In step number 1, we have to express f of z dz in terms of either x or y only. Step number 2, after writing f of z dz in terms of x or in terms of y only, then we have to change the limits. If we had written f of z dz in terms of x only, then we have to change the limits from x1 to x2, because we know z1 equal to x1 plus iota y1 and z2 equal to x2 plus iota y2. So in this case, z1 has to be replaced by x1 and z2 has to be replaced by x2. Again, if we had written f of z dz in terms of y only, then we have to change the limits from y1 to y2. So in this case, z1 has to be replaced by y1 and z2 has to be replaced by y2. Finally, in step number 3, we have to solve either this integral or this integral. Now, let us solve two problems. Problem number 1, evaluate integration 0 to 2 plus iota z bar whole square dz along the line y equal to x by 2. Second question, evaluate this integral along the real axis from z equal to 0 to z equal to 2 and then along a line parallel to y axis from z equal to 2 to z equal to 2 plus iota. Okay? Now, let us solve the problem number 1. So, according to problem number 1, we have to solve this integral along the line y equal to x by 2. So, let us solve. Integration 0 to 2 plus iota. We know that z equal to x plus iota y. So, therefore, z bar equal to x minus iota y, and again dz equal to dx plus iota dy. So, let us replace z bar by x minus iota y and dz by dx plus iota dy. So, we will get x minus iota y whole square into dx plus iota dy. Next, apply a minus b whole square formula. So, after applying a minus b whole square formula, we will get integration 0 to 2 plus iota x square minus y square minus iota into twice xy into dx plus iota dy. Next, our target is to write this part either in terms of x or in terms of y only by using this relation y equal to x by 2. For simplicity, I am going to write this part in terms of y only. So, since y equal to x by 2, so therefore x equal to twice y. So, therefore dx is equal to twice dy. Therefore, we get integration 0 to 2 plus iota z bar whole square into dz is equal to integration x square, which is equal to twice y whole square, minus y square minus iota into 2 into x, which is twice y into y, into dx plus iota dy. we have seen that dx equal to twice dy. So finally we get twice dy plus iota dy. Next, change the limits. Since everything is written in terms of y only, so we have to change the integral from 0 to 1, because here y1 equal to 0 and y2 equal to 1. So limit will be from 0 to 1. So after simplifying this part, we will get integration 0 to 1 4y square minus y square, that means 3y square, minus iota 4y square twice dy plus iota dy. Now let us take y square common from this term and dy common from this term. So finally we will get integration 0 to 1 y square into 3 minus 4 iota into 2 plus iota into dy. So finally we will get 3 minus 4 iota into 2 plus iota integration 0 to 1 y square dy. After simplifying this part, we will get 3 minus 4 iota into 2 plus iota into y cube divided by 3, limits 0 to 1. So after simplifying this part, we will get 5 by 3 into 2 minus iota, which is the answer. Now let us solve this second problem. According to this problem, we have to evaluate this integral along two paths. First part is along the real axis from z equal to 0 to z equal to 2, that means from 0 to a. And the second part is along a line parallel to y axis from z equal to 2 to z equal to 2 plus iota, that means from a to b. Now let us split this integral into two parts. First one is integration along path OA, z bar whole square into dz, plus integration along path AB, z bar whole square into dz. Now let us substitute the values of z bar and dz here. So after substituting and after simplifying, we will get integration along path OA x square minus y square minus iota into twice xy into dx plus iota dy, plus integration along path AB x square minus y square minus iota twice xy into dx plus iota dy. Now let us change the limits. We have seen that along OA y is 0 and along OA y is equal to 0 and dy is also equal to 0, and x varies from 0 to 2, 0 to 2, and along AB x equal to 2 and hence dx equal to 0, and y varies from 0 to 1 and y varies from 0 to 1. Now, let us substitute all these values in equation number 1. So, finally, we will get equation 1 implies integration 0 to 2 plus iota z bar whole square dz is equal to integration along path OA. Here the limit is 0 to 2 and y equal to 0 and dy equal to 0. So, finally, we will get x square dx plus integration along path AB. Along path AB, the limit is from 0 to 1 and x equal to 2 and dx equal to 0. So, finally, we will get 4 minus y square minus 4 iota y into iota dy. Now, let us simplify these terms. Integration x square dx x cube by 3 limit from 0 to 2 plus iota 4y minus y cube by 3 minus iota 4y square by 2. Limit is from 0 to 1. After substituting the limits and after simplifying, we will get 8 by 3 plus iota 4 minus 1 by 3 minus twice iota. So, after simplifying, we will get 1 by 3 into 14 plus 11 iota. Answer. This is all about today's video and I hope that you have learned a lot from this video.